In this video, we're going to be talking about section 3, which deals with decimals, integers, and real numbers. So the big idea behind this is, well, if somebody came up to you and asked, what is a decimal? What would you say? So hopefully you would first start off with a couple examples of what decimals actually look like. Like, for example, 1.5 or something like 3.14, which is a very famous number. It's an approximation for that famous number pi. But what decimals really represent are ratios. So decimals are just really ratios, and another way of saying ratio is that fancy word that we all love, a fraction. So, for example, we know that 10 to the 0 equals 1, okay? But what about 10 to the negative 1? Well, in order for us to fully understand this, there was a rule that we learned a long time ago called the negative exponent rule, and I'm not going to get too far into it, but what I want you to know is that 10 to the negative 1 is the same exact thing as 1 over 10 to the first power, and that is equivalent to 0.1. Now, let's kind of develop a pattern here so we can at least get some understanding. 10 to the negative 2, well, that's the same as 1 over 10 to the second, which is 0.01. And we'll do one more, because I think now you can start to see the pattern. 10 to the negative 3 is really 1 over 10 to the third, which is really 0.001. So, what we're developing here are all the decimal places. All right, so we're developing our decimal places. So, we have a number such as 438.001238. And what I'm going to do here is just kind of label each one of these decimal places. Now we know the 8 is in the ones position. We know the 3 is in the tens position. The 4 is in the hundreds position. And that pattern that we follow on the left also exists on the right. So the first 0, we would call this the tens position. The second 0, we would call this the hundreds position. The 1 is in the thousands position. This 2 would be in the 10 thousandths. Let me write that a little cleaner here. 10 thousandths position, and so forth. Okay? So, if somebody were to ask you, write the number let's say, we'll shorten this down a little bit, 438.013 in words. Okay, well, the first thing we would do is we always write the whole number first. So we're going to write this whole number first. So that would be 438. All right, that would be the first part. Second, you want to write your decimal. Now, the decimal is the word and. All right, so technically, if you looked at this number and you said 438.013, you would be incorrect because the word and means decimal. So this is 438 and then we write the decimal part. So finally we write this decimal part, and it's very easy. All we do is we go to the far right decimal place which would be right here. So we know the 0 is in the tenths, the 1 is the hundreds, the 3, so this would be thousands. All right? And what we would just write is 13, sorry, should be in words. 13 thousandths. And what we're going to do from here is we're going to take all three of these, so 438 and 13 thousandths, and just put them all together. 438 and 13 thousandths. And that's how we write decimals in words. All right, like I said, pretty straightforward. Just got to remember what's going on. Another thing we can do, just like in regular numbers, remember that expanded form from the previous section? Well, we can write expanded forms of decimals. And to do this, all right, we're just going to follow that pattern that we learned all the way up above. And that pattern that I'm talking about is right here. This is the pattern that I'm referring to. So as long as the decimal places keep going out, we just keep adding 10 to the negative whatever exponent. So let's go ahead, let's look at a number. We're going to do, in fact, let's just do the same number we've been working with. 438 and 13 thousandths. So if we wanted to write this in expanded form, we're going to take this one place value at a time. So I'm going to start right here in the middle of my page. You'll see the method to my madness in a second. So here's the ones position. So that's going to be 8 times 10 to the 0. Now, the 3, well, that's going to be, in fact, let me move this over a little bit more. So now the 3 is going to be 3 times 10 to the first, plus the 4 is 4 times 10 to the second. So directly underneath in red, what we're going to have is 400 plus 30 plus 8. All right, so that's the whole number part expanded. But now we're going to do the decimal part. And I'll do this in orange. So plus, now we have 0 times 10 to the negative 1. All right, which we know is just going to be plus 0. But it has a decimal now. All right, plus 1 times 10 to the negative 2. Well, we know that's going to be 0.01. And finally, plus 3 times 10 to the negative 3. So we know that's going to be plus 0.003. So now if I were to just stack all of these on top of each other, the 400, the 30, the 8, the 0.0, 0.01, 0.003, and added them, I'm going to go ahead in blue and just add a bunch of zeros just to keep my place values all in order. And hopefully you can develop an intuition on how these place values in our numbers actually work. So if we just added straight down the columns, notice we would get the same exact thing. So the next thing I would like us to go over would be to compare decimals. Now, once again, comparing decimals, it all falls back to place value. That's what we're looking at. Everything we do when we talk about numbers, especially numbers, is all about place values. Okay? So let's arrange the following from least to greatest. So in other words, we want to put the smallest number first, and then the next largest, and then the next largest, and so forth. So we're going to do 0.00396, 0.00407, and oops, too many zeros. 0.004. Now, the easiest way to do this, okay, is to look at place value. And since we're talking about decimals here, we're just going to go from left to right. So notice the whole number and all of them, and I'll use my highlighter. The whole number and all of them is a 0. So that's the same, so move to the right. The tens position, they're all zeros. The hundreds position, they're all zeros. And now we come up with the thousandth position. So we have a 3, a 4, and a 4. So when you think about this, when we look about this, notice that the 3 is our smallest value here. So that's going to be our smallest number. Now we're going to continue with the other two values. So they both have a 4. That's the same. They both have a 0. Now, this is a 0 here, and technically there's an infinite amount of zeros to the right of that, but we don't write them because how many zeros would be enough? That's why we don't write them. Next, we have a 7 and we have a 0. So once again, we're going to compare these two numbers now. And which one's smaller? The 0 is compared to the 7. So our next number would be 0.004. And then finally, 0.00407. All right. Now the next topic we're going to go over are integers. Now integers are positive and negative whole numbers including 0. So here's what they look like. We have these 3 dots, which just means to keep going to the left. And then we have 3 more dots that just says keep going to the right. So notice integers are not fractions. They are not decimals. They are whole numbers, but they're also positive and negative representations of them. Now, we use these all the time. Temperature readings, loans, measuring, we'll say height. Like for example, you have a mountain. So there's my picture of a mountain. Then at the bottom of the mountain, you have some water. So we would call that sea level. And then our little fishies live underneath it. So this would be like negative 30 feet of depth. So it doesn't mean that the numbers are getting smaller. What it means is that they are below a certain value. All right? So integers are very straightforward. There's nothing too crazy about them. All right? And then the last thing I want us to look at are these things called real numbers. All right. Now, real numbers is basically everything that we've ever been looking at. So, like, for example, if this is our universe, this is all the math, this is all the numbers that we know. All right? At the very center of our universe are going to be, oh, that looks bad. Are going to be the natural numbers. Then, when you come out of that, we have our whole numbers. Now, what makes the natural numbers different from the whole numbers? The whole number includes 0. Natural numbers start at 1. All right, so maybe I can write that on the right side here. Natural numbers, 1, 2, 3, and so forth. Whole numbers, 0, 1, 2, 3, and so forth. All right, so this is, if you remember from the first, I think it's the first or second section, we were talking about the evolution of counting and numbers and where did everything come from and how the Babylonians and the Egyptians did this. The first thing was we started at the natural numbers. Then 0 kicked in. Then we created what we call the whole numbers. Now we have another set. When banking and everything came in, and we call those integers. Let me try to write it down here where I have a little bit more space. All right, then we have our integers. Then we know the integers are -3, -2, -1, 0, 1, 2, and 3, and they keep going. Okay? Then in the previous week, we talked about fractions, and those are called ratios. All right? Those are called ratios, and ratios look like this. A over B, where A, comma B are integers, and this is the most important part, B is not allowed to equal 0. So that's what ratios are. So they're integers, okay? But that letter B is not allowed to equal 0. So if you think about this, all these things are like they're sitting on top of each other. So you got the universe, then you have the big circle of the ratios. Included within the ratios are the integers. Included within the integers are the whole numbers. Included within the whole numbers are natural numbers. But then we have this really weird one, and it's over here all by itself. And these are called irrational numbers. Now, there's no really fancy definition for irrational. Irrational numbers, we'll call them irrationals. Irrationals cannot be written as a ratio. All right, and we do have some very famous ones. The most famous is probably pi. There's no way to write pi as a fraction. All right, so let's not get this confused with like 1/3. Like 1/3 as a decimal is 0.33333 repeating. So ratios, they can be decimals because you got to be able to write it as a fraction. Pi, you can never ever write as a fraction. There's no two numbers that when you divide them, it always equals pi. All right? So when you have all of these numbers together, you could do something with all these numbers, which is you could put them on a number line. So we have 0, we have 1, we can even have 3, We can have 3.14, which is pi, so I'm just going to write pi. You could have negative 1/2. All right. You can have negative 10. You can have simply negative 1. You can have positive 3/4. Notice I'm giving you examples of everything that we have on the right side. I've given you examples of natural, whole numbers, integers, ratios, or rationals. When you have a number line, you can plot any number you want. And when you can do that, you have what we call the real numbers. So all of these sets of numbers, they all combine to give us what we call the real number system. And that's everything that we do. All right. Your book has a pretty decent picture of this, but I think the visual of this is a lot more powerful because you can see how they build on top of each other. And that's going to be it for this video. So enjoy.